Hey guys, so in this video, we are going to set up Pi-hole, but we're going to do it in a very specific way. In essence, we're going to have Pi-hole, we're going to have Unbound working with Pi-hole. Then we're going to use a tool to sync multiple Pi-hole instances together. And what that will allow us to do is ensure that if we create a DNS record on our primary instance, it will automatically sync over to our secondary and tertiary, which we'll get to. But the idea behind it is that we're managing one individual instance of Pi-hole, and all of our ad lists and DNS records and basically all of our settings are going to stay up to date on all of them. Finally, the last thing that we're going to do is we're going to configure Keepalived. And ultimately what Keepalived does is it allows us to share a virtual IP address between our second and our third Pi-hole instance. Now, there are some routers out there that allow you to set and use, let's say, 3 different DNS servers. If you have one of those, that step might not be necessary. But for the majority of people, you're probably not going to have that. So what that service is going to do is it's basically going to allow us to use a virtual IP address in a high availability like scenario. So if the second Pi-hole instance goes down, the third one will automatically start to use that IP address. And at that point, you'll have high availability set up across those devices. Now, the one disclaimer I'll give is that none of this is new. There's a bunch of videos out there that go over a lot of this. I know Techno Tim did a video on Keepalived with Pi-hole, but we're just going to look at everything from A to Z. And I will link some of those resources down below because, like I said, I didn't come up with any of this. So just keep that in mind as we go through this. So the first thing that I want to say is that this is a lab environment. So in a perfect world, Pi-hole instance 2 and Pi-hole instance 3 here would be on different hardware. So Pi-hole instance 3 would be like a Raspberry Pi. That would be the better way of doing this. The second thing is that I set static IP addresses on all of these. So this is 150, 151, and 152. So we have to set up Pi-hole, Unbound, and basically all of this on all 3 instances. We're going to set it up on one, and then I'll set it up off camera on the second and the third. So I updated the system already, and the very first thing we're going to do is install curl. Now, curl allows us to run the Pi-hole scripts. Now, you should never just run scripts online that you find. I happen to trust this, but I'd recommend that you go and confirm the script that you're running and understand what you're actually doing. So as soon as you start to run it, it will start to install some of the dependencies that it needs, and then it's going to walk us through an installer. So I'm going to click OK, OK. This is the static IP address reminder. I'm going to continue through that. And then this part is actually not important because we're going to be using Unbound, but we'll get to that in a second. I selected Pi-hole. I am going to include the default list. I'm going to enable query logging. I'll show everything. And then it will run through and configure Pi-hole. So with that done, Pi-hole is actually set up and configured and you could start using it, but the web password is not defined yet. So we're going to set the password here. And after the password's set, we are going to reboot this. So with it back up, we can go to the IP address /admin and you will get brought to the login page. And after you log in, you will get brought to Pi-hole. So at this point, Pi-hole is configured. If you wanted to, you could stop right here and you could set your DNS server to be this IP address and it would start to work. You would have ad blocking and stuff like that. But we're going to keep building onto this. So the next thing that we're going to do is configure Unbound. Now, before we get to that, it's important to understand exactly what Unbound is. Unbound is a recursive DNS resolver. Ultimately, what that means is that rather than going to an upstream DNS provider, so generally you would go from your client device to Pi-hole, and Pi-hole would then forward that DNS request to the upstream provider that you selected as soon as it blocked the DNS requests. So at this point, we're not using an upstream DNS provider. We're going to basically be our own upstream DNS provider. So Unbound is a recursive DNS resolver. It will basically take that DNS request and it will go directly to the authoritative server. Now, Unbound is used for privacy. Generally, what ends up happening is that when you forward that request to an upstream DNS provider, that upstream DNS provider has the DNS request that you have sent. With this, you're not actually sending it to an upstream DNS provider. But what's important to know is that while this provides some privacy, it's not the end-all be-all for privacy. someone somewhere along the chain will get this DNS request. So keep that in mind. Now, there are ways that you can enhance Unbound even further. You can use DNS over HTTPS. You can use DNS over TLS. There's a lot that you could do. But for this case, we're just going to set up Pi-hole out of the box, and we'll be using it locally with our Pi-hole setup. So we're going to come back to our container here, and we are going to install Unbound. Now, after it's installed, we are going to access the Unbound configuration directory, and we're going to create a file. The file will be a Pi-hole configuration file, and it will be blank. Now, in the Unbound documentation, this is exactly what we're going to be copying. So I'm going to copy this, and the only thing I'm going to change here is I'm going to set IPv6 to no, because I'm not using that. Now, there's a lot that you could do inside of this file, and ultimately, it really is dependent on your requirements. This is a good generic setup, but you might want to customize this. For the majority of people, you probably don't have to, but you can. So I'm going to save that, and as soon as I do, we're going to restart the Unbound service, and then we're going to start to test it. So we're going to run 2 commands, and these are the commands that they suggest that you run down here. But the first one is going to return an answer. So you'll see here the status is no error. We get an IP address for the piehole.net website. Everything looks good. Now, the next thing we're going to test is DNSSEC. So we're going to come in here, and we're going to run this. It's going to time out. We're going to run it again. And what you'll see is that we get a serve fail status. So back in the documentation here, the first command should give a status report of serve fail. That's good. So now we're going to run the second, and we will receive a no error status, which is exactly what the documentation said that we should get. So at this point, Unbound is working properly, but it's not actually working with Pi-hole. So we're going to reboot this instance again, and I had to do this because I ran into problems without rebooting it. But as soon as it's back online, we are going to log into the Pi-hole web interface. And at this point, we're going to go to Settings and DNS. Now, what you'll see is these are the default upstream DNS providers. If you were not using Unbound, you could come in here and you can just check off one of them, and that would be the upstream DNS provider that you'd use. But for us, we are going to use a custom DNS server. Now, what's important to understand is that because Pi-hole is currently using port 53, we had to configure Unbound to use a different port. So in that configuration file here, what you'll see is the port we used is 5335. So we are going to come in here, and we're basically just going to copy this here and paste it down here. So 127.0.01 is the local host. 5335 is the Unbound port. So as soon as we save and apply that, in the custom DNS servers here, everything is configured properly. So what that means is that a DNS request will come in, Pi-hole will block it, and then it will forward it to the quote unquote upstream provider, which is actually not an upstream provider. It's our custom DNS Unbound service running locally. Now, if you wanted to stop at this point, you would have Pi-hole and Unbound working. And I'd recommend that you set up a second instance so that you have some redundancy there. But Pi-hole and Unbound is a very common option out there. We're just going to take this one step further. We're actually going to take it 2 steps further. The next thing that we're going to do is we're going to set it up so that our first Pi-hole instance will sync to our second and our third. So if we add any local DNS records, or we add any custom block lists, or we blacklist anything, whitelist anything, etc., that stuff will automatically sync from our first instance to our second and our third instance. So then we're only managing one, but all 3 of them will stay in sync. Now, the most popular option, at least I think, was a tool called Gravity Sync. There's a lot of videos out there. Unfortunately, that has been retired at this point. So there are 2 main options that I found: Orbital Sync and Nebula Sync. Nebula Sync is the one that I'm currently using. I feel like it's a little easier, but we're going to talk through it. The downside of it is, unfortunately, it runs using Docker. So if you're running Pi-hole, pretty good chance that you probably have Docker running. And to be clear, up to this point, if you wanted to run Pi-hole in a Docker container on other hardware, you could do that as well. You don't have to do it the way that I did. The way I did will show you how to do it on a Raspberry Pi or an LXC container, but you can run it inside of Docker. And I have videos and articles on that I will leave below. But this specific syncing service has to run inside of Docker. So that's where we're going to set it up. So I've been managing my Docker containers. I'm basically migrating over to Dockage right now. I believe that that's how you say it, but this is a very, very basic container. What we have here is the Nebula Sync container, and we're specifying a primary Pi-hole instance as well as the password. The password I'm using is just password, but then we're setting replicas. You can use as many of these as you want, and they're separated by a comma. So 151 is our second instance, and 152 is our third instance, and then password is the password to log into those. I believe that you could set the password in a secrets file, and that, to be clear, is the better way of doing it, but this is the way that I'm going to do it in this video. So if you look up the Nebula Sync Docker container, you can figure out how to do that. The only other thing I changed is I set this to be a star. By default, it will be a 0, and the 0 just means that it will run every hour. I want this to run every minute, so that's why it's going to stay this way. So with that done, we are going to deploy this, and then Nebula will start to sync on a minute-by-minute basis. So what you'll see is the sync is complete, but we didn't actually do anything. The other important thing that I forgot to mention is that I went in and configured the second and the third instances of those LXC containers off camera just so that they're all set up. So I'm going to log into them. And what you'll see is that they're all basically configured the same, but we haven't actually changed anything. So what I'm going to do is come in here to the domains here. And what you're going to see is that nothing has been added. So I'm just going to come in here and I'm going to blacklist yahoo.com. And if we come in here and refresh, what you'll see is that nothing exists. So if we go back to the actual container, we're going to wait for this to sync. Okay, so the sync just finished. So if we come in here and we refresh this, you will see that yahoo.com was added to both. So we could do the same thing with a local DNS record. Adding a local DNS record to our primary Pi-hole instance. And after the sync is completed, if we go to the local DNS records, you will see that it has been added to both of those. So we only added it to the primary, and then the second and the third instances are kept up to date. So what's important to understand is that if you add something to the second or the third instance, it's not going to sync back to the first or any of the other ones. You have to manage everything through this one interface. So now that we have Pi-hole properly syncing from our primary instance to our secondary and our tertiary, what we're going to set up is Keepalived. Now, Keepalived is for high availability. So what we're going to do is set up a virtual IP address that's going to be shared between our second and our third instance. And at that point, if the second instance goes down, the second will be our primary. If the second goes down, the third will automatically pick up, and it'll be using the exact same IP address. TechnoTim did a great video on this that I'll link below if you really want to understand it at a more granular level, because we're not really going to get into it. But the only thing to stress here is that in a perfect world, this would be different hardware. So like I said, we're using a lab environment here, but this would be like a Raspberry Pi. The third device would be a Raspberry Pi, something that's on different hardware. So if the primary hardware goes down, the backup hardware will pick up. So what we're going to do is come into our second instance here, and we are going to install Keepalived. And then we're also going to do the same on the third. So we're going to go back to the second instance, and we're just going to run IPA. And what we need to get is the interface name. So you'll see here ETH0 IF61. All we need is ETH0. This is because it is an LXC container, but all we need here is ETH0. We need to add that to our configuration file. So what we're going to do is create a configuration file that will be blank for our second instance. And I'm going to paste this in. I will leave all these commands in the description in an article, but we're going to quickly talk through this. So this is going to be our master node. So what that means is that the primary for this virtual IP address is going to be this LXC Pi-hole 2 container. So that's the master. ETH0 is the interface that we just found. Virtual router ID. This doesn't matter. It just has to be something unique. So for me, I'm going to be using 198 so that it matches. Next is going to be the unicast source IP address. So that is the IP address of this specific LXC container. And then the peer IP address is the IP address of its peer. So this is LXC2, this is LXC3. Priority. The higher the priority, the higher the priority, if that makes sense. Probably doesn't. So if you had 10 and 20, which is what we're currently using, 20 should be on the primary instance and 10 should be on the backup instance, and that's how it's configured. This is just the authentication password, and then this is the IP address that we're using for our virtual IP address. This is something that cannot be in use. If it's in use, it's not going to work. So we're going to save this, and then we have to go to our backup instance and create the same file, but there's going to be a few differences. The state is going to be backup rather than master. ETH0 is the same interface name. You have to get the interface name the same way you did, especially if it's a different device, make sure you're using the correct one. The unicast source IP is going to be the IP address of this instance, which is 152. The peer is going to be 151 because that's the second. The priority is 10, so this is a lower priority device than the master. The same password and then the same virtual IP address. So we're going to save this. We're going to go back to our second instance, and then we're going to enable the service, and we're going to do the same now on the third instance. So with that done, we are going to reboot everything, and I'm going to do the same over here. And with it rebooted, we are going to check the status. So what you're going to see is that it's active, it's running, and it is entering the master state. So right now, the second instance is the master. And if we run the same command on our third instance, what you'll see is that it is the backup. So at this point, what we're going to do is we are going to start a constant ping on that virtual IP address. And the next thing we're going to do is we're just going to come in here and we're going to shut down that second instance. So with it disconnected, what you'll see is that we did have one dropped ping, but it also picked right up right after that. So if we come back into this and we check the status again, what you'll see is that it entered the master state. So it entered the master state because it's set up as the backup and the master went offline. So if we come back in here and we start this up, what you'll see is that now that it's back up, we are back to entering a backup state. So right now, high availability is working properly. So at this point, high availability is working properly. We have 3 Pi-hole instances. The first is set as the primary. The second and the third are set under one virtual IP address. And at that point, if the second goes down or the third goes down, everything should still continue to work. Now, again, in a perfect world, you would have this all on different hardware. And even in this case, in my virtual environment here, I have high availability set up in Proxmox. So there's high availability in Proxmox, but there's also high availability in those 2 LXC containers. So this is not the most realistic example, but I just wanted to show you how this works. So the final step in all of this is just changing your DNS server. So let's quickly look at that. So I use a Unify router, and there's 2 main ways that you could set it here. The first is if you just want everything to be able to access it. Now, keep in mind, if you have multiple VLANs, you have to make sure that everything can access one another. So that's important to understand. So in that case, you probably wouldn't want to do it this way. But if you just wanted to blanket cover everything, in the internet section for your primary WAN, you would come in here and in the DNS section, you would add in the primary Pi-hole IP address that we had, and then the virtual IP address. So if I apply these changes, so with those changes applied, what you can see is that we are now getting DNS requests. And you can go in here and modify Pi-hole as much or as little as you want, and it will continue to block ads based on your ad lists and stuff like that. Now, if you didn't want to set it this way, what you would do is in the individual VLAN itself, you would come down into the DHCP settings and you can uncheck auto here, and then you can specify the DNS servers. So the benefit in doing it this way is that the DHCP server will be handing out the direct IP address of your Pi-hole instances. So at that point, all of the actual clients and stuff like that would work. You would know exactly where the traffic is coming from, etc. So the downside of doing it this way, if you're a Unify user, is that some of the blocking settings, so like simple app blocking and stuff like that, won't work properly because you're not using this anymore as a DNS server, so they can't do any DNS filtering. Pluses and minuses, but it's ultimately up to you. So at this point, we have configured just about everything. Pi-hole is configured. 2 other Pi-hole instances are configured. There is automatic syncing set up between them. Unbound is working on all 3 of them. High availability is configured on the second and the third. And overall, everything should just work. So while this is set up in a lab environment, your setup is going to be slightly different. You can use Docker if you want. You can use various different types of hardware. There's not really a right or wrong way of doing this. But what is important is that you're using different physical devices so that you have some redundancy. But again, I have all those commands in the description if you want to follow along. But if you have any questions, please feel free to leave those in the comments. But if you made it this far, thank you very much for watching. I will see you guys next time.